Hi dear student, this particular class I am going to discuss about the equation of chord of contact. What is a chord of contact first of all? This is the circle. Let us say the circle equation is S is equal to 0. To this circle from an external point, let us say the point is P x1 y1. From an external point we are drawing a tangent. This is the tangent, and here another tangent is also possible like this. So from a point P x1 y1, these are the two tangents drawn. These two tangents touches the circle at a point A and B. That from an external point we can draw two tangents. These two tangents touches the circle at A and B. Now this is the chord passing through A comma B. A chord passing through A comma B. This is called chord of contact of a point P x1 y1 with respect to the circle S is equal to 0. For the circle S is equal to 0. For the circle S is equal to 0 with respect to the point P x1 y1, this is called the chord of contact. The equation of this chord of contact, that means this line equation is given by S1 is equals to 0. Sir, how we are getting this S1 is equal to 0? Don't confuse. Earlier to the circle at a point x1 y1, because the point x1 y1 is on the circle. At a point x1 y1, a tangent is drawn. The equation of the tangent is S1 is equal to 0. Now here is what? Point P x1 y1 is here. From this point we are drawing two tangents. Those two tangents touches the circle at A and B. A chord passing through A comma B is called the chord of contact of a point P x1 y1 with respect to the circle S is equal to 0. The equation of this chord of contact is S1 is equal to 0. Okay, I am assuming this point of contact is x2 comma y2. This point of contact is x2 comma y2, and this point of contact I am taking it as x3 comma y3. Right? Now if the circle equation is S is equal to 0, now tell me at a point A, what is the equation of tangent? At a point A, the equation of tangent is S2 is equal to 0. Tangent drawn at a point x2 y2. The equation of this tangent is S2 is equal to 0. That means this line equation is S2 is equal to 0. But now this line is passing through the point x1 y1 or not? This line is passing through the point x1 y1. Substitute this point x1 y1 here. So we will get S12 is equals to 0. Next, in the similar way, to the same circle S is equal to 0, at a point x3 y3 a tangent is drawn. So what is the equation of tangent at a point x3 y3? S3 is equals to 0. But now this tangent is also passing through the point x1 y1. That's why we can say S13 is equals to 0. Now observe here, S12 is equal to 0. S13 is equal to 0. So what is the meaning of this? There is a line S1 is equal to 0. On the line S1 is equal to 0, x2 y2 point is there. On the line S1 is equal to 0, x2 y2 point is there. That's why we got this condition. On the line S1 is equal to 0, x3 y3 point is there. That's why we got this condition. So what is the meaning of that? This line equation is, because on this line x2 y2 point is there, x3 y3 point is there, so this line equation is nothing but S1 is equal to 0. So from a point x1 y1 to the circle S is equal to 0, tangents are drawn. Those two tangents touches the circle at capital A and capital B. A chord passing through A comma B is called chord of contact of a point P x1 y1 with respect to the circle S is equal to 0, and the equation of this chord of contact is S1 is equal to 0. Now I want to discuss a few important points here related to this particular idea. So this is the point Px1 y1 and A comma B, and let us say this is the center of the circle. The center of the circle is equal to, take C, a circle circumscribing the triangle PAB. This is the circle circumscribing the triangle PAB. This circle, no doubt, it passes through the center of this circle. A circle circumscribing the triangle PAB. This is the circle circumscribing the triangle PAB. That circle must passes through the center of the circle C. At the same time, observe here, I am joining C and P. CP joined. Let us take this point, center of the circle is 0 comma 0, whereas if you take the circle equation as x square plus y square is equal to a square. Okay, center of the circle is 0 comma 0. Now observe here, this is the line joining from Px1 y1 to the center. Now what I am doing is B connected with C. B is connected with C. Now what is this angle? Right angle. In the similar way, now I am connecting C with A. C is connected with A. Now tell me, what about this angle? Is also a right angle, because this is a tangent and this is a normal. Here also this is a tangent and this is normal, right? So now you know this angle is equals to theta by 2, and also you know this length of the tangent is equal to root over S11, and this is the radius of the circle is equal to A. This circle radius is equal to A. Observe here, CP must be the diameter for the circle circumscribing the triangle PAB. So a circle circumscribing the triangle PAB, to that circle CP is the diameter. That means definitely the middle point of CP is the center of the circle. But what is the middle point of CP? CP middle point is nothing but x1 plus 0 divided by 2, y1 plus 0 divided by 2. That is the center of this circle, right? A circle circumscribing the triangle PAB must passes through the center of the circle, given circle. For that circle, CP is the diameter, right? Now one more important question here I am going to discuss is, what is the area of the triangle PAB? Before going to discuss the area of a triangle PAB, I hope so everyone know about this particular idea, as we discussed in the last class, that is about the sine rule. What is the sine rule? So now observe here, this is the triangle PAB. We want to find out the area of this triangle PAB. PAB triangle area is required. All of you observe here. You know A by sine A is equals to B by sine B is equals to C by sine C. That must be equals to 2R. That is a sine rule. At the same time, we discussed in the earlier classes about the cosine rule also. This is A, capital A. This is B and capital B. And this is C, and this is side of the triangle, and this is a capital C. Now from this I can write a square is equal to b square plus c square minus 2bc into cos a. At the same time we can write b square is equal to a square plus c square minus 2ac into cos b. Observe the triangle. Similarly we can write c square is equal to a square plus b square minus 2ab into cos c. So we can write c square is equal to a square plus b square minus 2 times ab into cos c. So this we are calling it as cosine rule. Now we want to find out the area of a triangle. How to find out the area of a triangle ABC? Let us take, this is the triangle ABC triangle. Now from this a line is drawn perpendicularly. What is the area of the triangle? Half into base is equal to BC into height is equal to say h. You know very well this BC is nothing but small a. That's why area of the triangle we can call it as a delta. Delta is equals to half into BC is equal to small a. Now from this diagram tell me what is the sin C? Sin C is equal to h by AC. AC is nothing but small b. Therefore we are getting h is equals to b into sin C. That's why in place of h we can write b into sin C. That is the area of a triangle. AB half into A into B into included angle. Half into AB into sin C. In the same way we can write the area of this triangle as half into AC we are writing means half into AC we are writing means we have to include this angle, that is sin B. Another way also we can write half into, we are writing BC. Half into BC means we have to write this one as sin A. So that's why that is another formula for area of a triangle. You already know Heron's formula for finding the area of a triangle. Delta is equal to square root of S into S minus A into S minus B into S minus C. That is the formula for finding the area of a triangle. Right? Now here we discuss the area of a triangle is equal to half into AB into sin C or half into AC into sin B or half into BC into sin A. Now from this can you tell me what is the sin A? From sine rule we can write sin A is equal to A by 2R, or we can write sin B is equal to B by 2R, or we can write sin C is equal to C by 2R. Now in place of sin A I am writing A by 2R. If you write A by 2R, what happens? ABC divided by 4R. That is also the area of a triangle. Delta is equal to ABC divided by 4R is the area of a triangle. Once again you can observe here, we got the information area of the triangle is equal to half into BC into sin A. Now the same I am going to discuss in another way here, half into, according to the sine rule, in place of B we can write 2R sin B, in place of C we can write 2R sin C. That's why in place of B we are writing 2R sin B, in place of C we are writing 2R sin C is multiplied with sin A. Now 2 gets cancelled. We are getting this one as 2R square sin A sin B sin C. That is another formula for finding the area of a triangle. Just a minute. Area of a triangle, you know, half into base into height. From that we discussed another formula, half into AB into sin C. From this we discussed another formula, delta is equal to ABC by 4R. And from again here we discussed another formula, delta is equals to 2r square into sin A into sin B into sin C, and this is your known formula. Delta is equal to square root of s into s minus A into s minus B into s minus C. These are the different formulas for finding the area of a triangle. So now I am going to use this particular formula, product of the sides divided by 2 into sine of angle between those two sides. Product of the sides divided by 2 into sine of angle between those two sides. Now I am asking you to find the area of a triangle PAB. We have to find out the area of a triangle PAB. As I told, this particular angle is equals to theta. Now earlier also we discussed this is the radius of the circle, right? And this angle is equals to theta by 2. This is the length of the tangent, we know, root over s11. This is also the length of the tangent, that is also equal to root over s11. I hope so everyone know tan theta by 2 is equals to, we discussed in the earlier classes, tan theta by 2 is equals to a divided by root over s11. Tan theta by 2 is equals to opposite side by adjacent side, a by root over s11. Tan theta by 2 is equals to, we know the formula for sin theta. What is the sin theta formula in terms of tan? 2 tan theta by 2 divided by 1 plus tan square theta by 2. Sin theta is equals to 2 tan theta divided by 1 plus tan square theta by 2. That is the formula for sin theta. Now I can write this one as 2 into tan theta by 2 can be replaced with a by root over s11 by 1 plus, we can write here a square divided by s11, right? Now what about this simplification? That simplification we can do it like this: 2 times a into root over s11 by s11 plus a square. That is the value of sin theta we got. I hope so everyone followed, because here by root over s11, here root over s11, both one time cancelled, you left with root over s11, right? So that is sin theta value. Why we are finding sin theta value, I will discuss here. So we have to find out the area of a triangle PAB. For finding the area of a triangle PAB, what we can apply? Half into product of the sides PA into PB into sine of angle between those two sides. Area of a triangle PAB is equals to delta. The delta is equals to half into product of the sides PA into PB into sine theta, where theta is angle between the sides. That can be written as half into, you know, PA is equal to length of the tangent, that is root over s11. PB is also the length of the tangent, that is root over s11. And just now we got sin theta value is equals to 2a into root over s11 divided by s11 plus a square. Now here 2 and 2 gets cancelled, so we are getting a into s11 power 3 by 2 divided by a square plus s11. That is the area of a triangle PAB, right? So that is the discussion regarding chord of contact. The first point we discussed is a circle circumscribing the triangle PAB. A circle circumscribing the triangle PAB must passes through the center of the circle. That circle circumscribing the triangle PAB, that circle center is nothing but the middle point of CP. Next, we are getting the triangle PAB. The area of the triangle PAB we calculated. We got the area of a triangle PAB as a into s11 power 3 by 2 divided by a square plus s11. So here one more point we are going to discuss. So this is the information we have. Now what I am doing here is, we got the chord of contact equation as S1 is equal to 0. But when the circle equation is x square plus y square is equal to a square is the circle equation. You know what is S1? S1 is nothing but x x1 plus y y1 minus a square, that is S1 is equal to 0. Now you know this particular point is x1 y1. Can you tell me what is the slope of this chord of contact? That means this line slope is how much? This line slope is equal to minus x1 divided by y1. Now can anyone tell me what is the slope of CP? Slope of CP is equals to y1 divided by x1. You can observe the chord of contact and CP, the line joining from center to the point Px1 y1. These two are always perpendicular. That is the first point. These two are always perpendicular. Line joining from center to the point Px1 y1 is perpendicular to the chord of contact. Let us say this particular point is equals to Q. Right? But this angle is equals to 90. Let us say this angle is equals to theta. This is a triangle. Observe this particular triangle. In this triangle, that means the triangle name is also I am saying PBC triangle. In the triangle PBC, this angle is equal to say theta, and this is 90 degrees because angle between a tangent and normal. Now can you say what about this angle? 90 and this is theta. What about that angle? That angle must be 90 plus theta, right? This is 90 and this is theta. So no doubt that angle must be 90 minus theta is that angle. Okay, we got this angle is equals to 90 minus theta, right? Then what we can write from this diagram? From this diagram we can write sin theta is equals to just you can observe there sin theta we can write it as from the triangle CBP. From this triangle, what is the sin theta? Sin theta is equals to radius A divided by CP. Therefore we are getting sin theta is equal to A by CP we got. As we know from this angle we got 90 minus theta, and you know this is equals to 90 degrees. What about this angle? Just observe this triangle BQC. In this triangle this angle must be theta. Now again observe there, from that we will get sin theta is equals to CQ divided by A, right? Now sin theta is equal to CQ divided by A. CQ divided by A is equals to A by CP. Now you can observe CP into CQ is equal to A square. CP into CQ is equal to A square. So this is the particular point. We can say P comma Q are called inverse points. P comma Q are said to be inverse points of a circle S is equal to 0 if it satisfies the following three conditions. The first condition is C comma center of the circle P comma Q or collinear. C comma P comma Q are collinear. And the next point, the second point is P comma Q lie same side to the center. Yes, you can observe in the diagram, P comma Q are there same side to the center. P comma Q lie same side to the center. And the third point is CP into CQ must be equal to R square, that is radius of the circle is A. So P comma Q are said to be inverse points of a circle S is equal to 0. It has to satisfy the following conditions. C comma P comma Q are collinear. P comma Q lie same side to the center. CP into CQ is equal to R square or radius square. Here A square. Now, sir, I know the circle equation and I know the point P also. But then how to find out the inverse point of P? So P point you know, then how to find out the coordinates of Q? Yes, you can find out the chord of contact equation. S1 is equal to 0. That means you know this line S1 is equal to 0 and you know this point as Px1 y1. From a point Px1 y1, foot of the perpendicular, right? So the inverse point of P with respect to the circle S is equal to 0 is Q. How to get the coordinates of Q? Q is the foot of the perpendicular from a point Px1 y1 on to the chord of contact, right? So that is about the another important idea on this particular information. So before going to conclude this particular idea, just I want to discuss one question which is given in this year JEE exam. The question is saying like this: O be the center of the circle. No doubt, circle is given as x square plus y square is equal to r square is the circle equation given, whereas r is greater than root 5 by 2 also given. That circle center is given as 0 comma 0, right? So that circle center is origin. No doubt, center of the circle is 0 comma 0 and radius is equals to r. Suppose PQ is a chord of the circle and the equation of a line passing through P and Q. This is given as chord. This point is given as P and this point is given as Q. In the question they have mentioned about this line also. That line equation is given as 2x plus 4y is equals to 5. That is the information given. Now at a point P, a tangent is drawn. At a point Q also a tangent is drawn. Yes, these two tangents are intersecting at some particular point. It is immaterial for us. Nothing mentioned about this. If the center of the circumcircle of the triangle OPQ, this is O P Q triangle, OPQ triangle circumcircle. No doubt, this is the circumcircle of the triangle OPQ that must passes through the tangents point of intersection. He is asking as given in the question. This is the circumcircle of the triangle OPQ. This circumcircle of the triangle OPQ lie on the line x plus 2y is equals to 4. Let us say this is the circumcenter of the triangle. Now this is the line given. This line equation is given as x plus 2y is equals to 4. Once again check it. Chord PQ equation is given as 2x plus 4y is equal to 5. Right? Center of the circle is given as 0 comma 0. Now OPQ is a triangle. A circle is circumscribing the triangle OPQ. That circle has a center. That center line equation is given as x plus 2y is equal to 4. And he is saying that this circle center lie on this line given. Okay, see. So one point what we know is a circle circumscribing the triangle OPQ must passes through, say this point as R, must passes to the point R. That is the discussion we did earlier. Okay, a circle circumscribing the triangle PAB must passes through the center of the circle we discussed. Because this is the circle, tangents drawn. This is called the chord of contact. A circle is circumscribing this triangle PAB must passes through the center of this circle we discussed. The same diagram there also. Now what I am doing is I am assuming this point R coordinates as x1 comma y1. But for this point x1 y1 with respect to the circle S is equal to 0, what is the chord of contact equation? The chord of contact equation is S1 is equal to 0. That is nothing but x1 plus y1 minus r square is equal to 0. Chord of contact equation. But the chord of contact equation is given in the question as 2x plus 4y minus 5 is equal to 0 given. Now compare these two. You will get x1 divided by 2 is equals to y1 divided by 4 is equals to minus r square divided by minus 5. Therefore we are getting x1 by 2 is equals to r square by 5 and y1 by 2 is equals to 2r square by 5. Sir, why you are finding x1 by 2 and y1 by 2, sir? x1 by 2, y1 by 2 is the center of this circumcircle, because as we discussed, this is OP is the diameter, OR is the diameter for the circle. Earlier we discussed as CP is the diameter for the circle. CP middle point is the center of the circle. That's why here also OR middle point is the center of the circle. That circle center is x1 by 2 comma y1 by 2. This center, this middle point must lie on the line x plus 2y is equal to 4. That's why this point is the middle point, or this is the thing but the center of the circle. What is the center of the circle? R square by 5 comma 2r square by 5. That is the center of the circle. This circle center must lie on the line x plus 2y is equal to 4. Substitute here. Then what happens? In place of x we have to write r square by 5 plus 2 into, in place of y we have to write 2r square by 5 is equals to 4. Therefore we are getting r square is equals to 4, radius is equals to 2 you will get, right? So that is the question which is given in this year JEE. Now here one more particular point. This particular circle equation is S is equal to 0 and this point is x1 y1. Now you are observing two tangents are not. What is the combined equation of those two tangents? These two tangents combined equation is given by S1 square is equal to S11. That is the combined equation of pair of tangents from pair of straight lines. You will get this equation represent two straight lines. So that's why the combined equation of this is one tangent, this is another tangent. These two tangents combined equation is given by S1 square is equal to S11. So that is the discussion regarding this particular idea. Okay, bye bye.